Another short and sweet video in one-dimensional motion, this time with us knowing only the final distance and the final velocity as our starting point. Well, how do we get ourselves out of this? Well, first, what do you know? What do you want to know? And what can you assume? We're on planet Earth. I didn't tell you what the initials were, so therefore 0 seconds, 0 meters. So we have this in meters per second. So what do we know? What do we want to know? Well, let's take a look at some of our relationships here. I don't know time, so that kind of forces me to take a look at the formula that doesn't have a D in it. Can I use this, or without a T in it, can I use this to help me solve for something else? Yeah, if I rearrange it, average acceleration is velocity final squared minus velocity initial over 2D. So at that point, we can say, okay, let's just do it. A equals velocity final squared minus velocity initial squared, 2 times the distance. We go over here, we have 250 meters, and we have a 25 and a 0. So this becomes 25 meters per second squared minus 0 meters per second squared. Actually, this should be up here. Divided by 2 times the distance, which was 250 meters. Pull up the calculator. Should be 625, but let's double check. 25 squared, 625 meters squared, second squared, basically times 1 over 500 meters. That way I can see the cancellations. Divide by 500, and this tells me that my average acceleration is 1.25 meters per second squared. Go back over on the other side. 1.25 meters per second squared. And at this point, can I also figure out my average velocity? Of course I can, which would be here. 25 plus 0 is still 25, divided by 2 is 12.5. This gives me 12.5 meters per second. Now I could solve this for t, or I can go back to here and say delta t is delta v over a. Well, let's do that one for fun. Delta t equals delta v over a average. Well, my change in velocity was 25 meters per second over 1.25 meters per second squared. Cancel, 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 and I get 12.5 divided by 1.25, or 10 seconds. So delta t is 10 seconds. And of course, time final would be the same, 10 seconds. And at this point, I don't have any blanks left. Oh, change in velocity. Well, we know the average is this. 25 minus 0 is 25 meters per second. And we are done.